Okay, so in this video I'm going to use DeMoivres' theorem to prove a trigonometric identity. In particular, I'm going to use it to prove this particular one here: sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. Now I'm going to start here by taking cos theta plus I sine theta, and I'm going to raise this to the power of 3. And the reason I'm raising it to the power of 3 is because the highest power I have along here is 3. Sine is raised to the power of 3 here. If I had sine to the power of 4 here, I would raise this to the power of 4, and so on. So let's have a look at expanding this first. So I'm just going to expand this by effectively multiplying what's inside the bracket by itself 3 times. Once I've done that, then I'm going to use DeMoivres' theorem to write it a different way, and then I'm going to have a look at equating either the real parts or the imaginary parts of both solutions. So let's have a look at just expanding it first, multiplying it by itself 3 times. Now I'm not going to physically do that. What I'm actually going to do is just use the binomial expansion method. So let's see. If I expand that using the binomial expansion, I should start by writing 3, 0 here. 3 choose 0. Now this will be cos cubed theta. So that's my first term. I would raise the second term here to the power of 0, which will just give me 1, so I won't include the 1 here. Now my second term then is plus 3 choose 1. My first term here will be cos squared theta this time. Remember, you start with the highest power here, and it reduces by 1 each time. So I went from cos cubed theta to cos squared theta. Next time it'll be cos to the power of 1 theta, and then cos to the power of 0 theta. But at this stage I need to introduce the second term here, which is I sine theta. So it's I sine theta here, and this is to the power of 1. Remember, this second term here was to the power of 0 for this part, so it was just 1. Here I'm raising it to the power of 1, and the next term I'll raise it to the power of 2, and then to the power of 3 finally. So let's do the next term then. That's going to be 3 choose 2 as my coefficient. I had cos cubed, cos squared, so this time it's just cos to the power of 1 theta, and I'm going to raise my second term then to the power of 2, so it's I sine theta squared. Okay, so I have 1, 2, 3 terms so far. My last term then, I'll just come down here, will be plus. This time it'll be 3 choose 3. Cos theta will be to the power of 0, which is 1, so I won't write that in here. And then my second term, this second term here, I sine theta will be raised to the power of 3. So I've expanded this out using the binomial expansion, so I'll just simplify that now. Let's see, what will this become? Let's see, this will be 3, 0. 3 choose 0 here is just 1. So I just end up with cos cubed theta. 3, 1. 3 choose 1 here is just 3, so I'll put in a 3 here. Cos squared theta. And then I sine squared theta here. So I'll just put the sine theta here, and then I'll just put the I on the outside here. It's the same thing. Okay. Now this term here, now if I look at this term here, first of all I've got a 3 choose 2. 3 choose 2 is the same as 3 choose 1 by the twin rule. So I should end up with 3 here anyway. Now I haven't put in a sign here yet because I just want to have a look at this part here. I've also got a cos theta here, so I'm just going to put in cos theta here. Now I've got a sine squared theta here as well, so I'm just going to put in sine squared theta because I'm squaring it here. Now this I is also squared, so if I square I get minus 1, so this becomes minus here. So I end up with 3 minus 3 cos theta sine squared theta. And the last term then, it's going to be, let's see, 3 choose 3 is just going to be 1. And then I've got sine cubed theta. That's going to be sine cubed theta here. And I've also got to cube this I here. Now remember, I is just simply square root of minus 1. So you've got square root of minus 1 times square root of minus 1 times square root of minus 1. So minus 1, square root of minus 1 times square root of minus 1 is minus 1. Square root of minus 1 is I. So I end up with just simply minus I. So really what I end up with here is a minus anyway, and then I've got the I as well here. So that's everything expanded. So what I might just do now is just simply put the real parts together and the imaginary parts together. So the real parts would be this part here and this part here. They don't have any i's attached to them. So let's see, we'll put in cos cubed theta minus 3 cos theta sine squared theta. So that's these two parts here. Now I'm going to put these two together here, and I'm actually going to factorize them as well. I'm going to put the I outside the bracket here because we've got an I here and an I here. So I end up with plus 3 cos squared theta sine theta, that's this part here, and then I've got a minus, that's this minus here, sine cubed theta, and I have the I outside the bracket here. There's an I in both of these, so I just factorized it. So really now I've got a complex number here, if you like, with a real part. This is my real part here, and this is my imaginary part here. So that's as much as I can do with that. So all I've done is expanded this here using the binomial expansion. So let's write it another way. So this time I'm just going to use DeMoivres theorem. So what do we start with? We've got cos theta plus I sine theta, and we're raising it to the power of 3. So using DeMoivres theorem, then we know that that's just simply that's just cos 3 theta plus I sine 3 theta. That's using DeMoivres theorem. You can put the 3 or the power down here in front of the angle, multiplied by the angle here. So okay, so now we know that cos theta plus I sine theta cubed is equal to this here by the binomial expansion. It's also equal to this part here using DeMoivres theorem. So all of this here is equal to all of this here. Now let's go back to our original identity. What did we need to prove? Well, we needed to show that sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. So we need a sine 3 theta. So if we look here, we have sine 3 theta here, and this should be equal to the imaginary part here. That should be equal to this part here. So let's write that out. Let's see what we can do with that. So let's see. We have sine 3 theta from here is equal, should be equal to all of this here. So that's equal to 3 cos squared theta sine theta minus sine cubed theta. Okay, so now we have an identity here with sine cubed theta in it, which is what we were looking for, but the right hand side doesn't look like this here. We need a 3 sine theta and a 4 sine cubed theta, minus 4 sine cubed theta. So let's see what we can do with the right hand side here. Now, so we write this down again, sine 3 theta is equal to, now we have a cos squared theta in here, which we don't want. So we don't have any cos's in our original identity, so let's change that. We know that sine squared plus cos squared is equal to 1, so that means cos squared is equal to 1 minus sine squared theta. Sine theta minus sine cubed theta. Okay, so now we have everything on the right hand side with signs in them. We've no cos's, so that's perfect. But it still doesn't look like the right hand side of our identity, so let's continue on. We have sine 3 theta here on the left hand side. Let's just multiply this out. We have 3 minus 3 sine squared theta sine theta minus sine cube theta. Okay, so let's see, we could oh sorry, yeah, this was actually, I just multiplied out this part here actually. So what I've got here is 3 times 1 is 3, 3 times sine squared theta is 3 sine squared theta, but it's also multiplied by this sine theta here, so I've got to do that as well. So let's just do that as well. So we have sine 3 theta is equal to sine theta times 3 is 3 sine theta. We have minus 3 sine squared theta times sine theta, so that will give us minus 3 sine cubed theta minus sine cubed theta. So that will give us sine 3 theta is equal to 3 sine theta. Now we have minus 3 sine cubed theta minus 1 sine cubed theta. So that will give us minus 4 of these sine cubed theta. Now I think this is what we were required to prove. Let me just double check that. We have 3 sine theta minus 4 sine cubed theta. So we have 3 sine theta minus 4 sine cubed theta. So we have ended up with what we were required to prove. So we proved our identity. So just to recap, all we really did was we looked at what we were required to prove. We saw that we had a sine cubed theta in there. So we started with cos theta plus I sine theta. We raised it to the power of 3 because the highest power in our identity in our equation here was 3, because we needed to end up with a sine cubed theta somewhere. So we looked at this in 2 different ways. First of all, we expanded it using the binomial expansion. Secondly, we used DeMoivres theorem to bring the 3 down here and the 3 in here. Then we simply equated both imaginary parts, this part here and this part here. We manipulated the right hand side in order to we manipulated the right hand side in order to make our identity or end up with this part, the right hand side of our identity here. So that's it.